I'm going to show you how to easily solve rates of change and differential equations questions. So a cuboid tank is being filled with juice and the measurements are given in this diagram. The time t minutes after juice started flowing into the tank, the height of the juice was h meters and its volume was v meters cubed. The rate of change of v is inversely proportional to the square root of h. Show that dh by dt is equal to mu over the square root of h, where mu is a constant. So for part A, first see what you want to have, alright? So we want dh by dt. Then we're going to look at the information given and see if we can make any equations from that. So this bullet point here is quite obvious to use first. So the rate of change of v means that dv over dt is inversely proportional to the square root of h. So it will look like this. We could rewrite it using a constant, so it would look like k over root h. So we want dh by dt, right? So dh by dt could be equal to dv by dt, and we want a dh on top, right? So let's multiply that by dh and divide through by dv. So we need to have an equation in terms of v and h. Well, what other information do we have here? This bit. The height of the juice is h meters and its volume is v meters cubed. So let's find the volume in terms of h. So v is going to be equal to, we have the base is 20 times 10 and the height is h. So v equals 20 times 10 times h, which is just equal to 200h. So therefore dv by dh is going to be equal to 200. Now all we have to do is multiply this using the chain rule. So this leads to dh by dt equals dv by dt. Well, dv by dt is k over root h multiplied by dh by dv. So all we have to do is the reciprocal of this. So that's 1 over 200. That's going to give me k over 200 root h. They told me that mu is a constant, so we could just say where mu equals k over 200. So that's how you do part A. Part B gives us some more information. Initially, the height of the juice was 1.44 meters, and after 8 minutes of the juice flowing in, the level reached 3.24 meters. Find an equation for h in the form, and the form is given below. So let's note down the information they've given us from words to numbers. So initially, the height is 1.44. That means that at t equals 0, h equals 1.44 meters. All right? And then it tells us that at t equals 8, h is 3.24. So t equals 8, h equals 3.24. What we're doing is just solving this differential equation. So the differential equation is dh by dt is equal to mu over the square root of h. Notice we could just use mu as our constant here. So now, if I just rearrange this, having the h's on one side and the non-h terms on the other side, I get square root of h dh equals mu dt. And I can integrate both sides. So here I'm just integrating h to the power of a half, so that becomes h to 3 over 2 divided by that is that. That's equal to mu t plus a constant. So now I can just sub in this and this. So at t equals 0, I have 2/3 of 1.44 to the 3 over 2 equals c. So therefore, c is going to be equal to 1.152. And then at t equals 8, 2/3 of h, which is 3.24, 3 over 2 equals 8 mu plus 1.152. So 8 mu is going to be equal to 342 over 125. If I subtract this, then that means that mu is going to be equal to 0.342. So now I have my values, I can just sub in. So I have 2/3 h to the 3 over 2 is equal to 0.342 mu t, plus 1.152. And the question doesn't want any coefficients with h, so all I have to do is multiply by 3 over 2, and I get h cubed is equal to 0.513 t plus 1.728, and that is my final answer to this rates of change and differential equation question.